Hi friends, welcome back. Let's discuss the next questions on static timing analysis. And I would like to mention that this question is very important from interview perspective. So let's concentrate fully on this particular question. So friends, here we are asked to find the maximum clock frequency of the given below circuit if clock to Q delay of both flip-flop is 2 nanosecond. Setup and hold time for flip-flop 1 is 2 nanosecond and for flip-flop 2 is 3 nanosecond and the multiplexer delay is 0.5 nanosecond. So friends, if you see this question carefully or if you see this circuit diagram carefully, there are more than one timing paths in this circuit. So the first timing path is starting from the clock pin of the flip-flop 1 and it will end at the data pin of the flip-flop 2. This is, let's call it timing path 1. And the second register to register timing path is starting from the clock pin of the flip-flop 2 and it is ending at the data pin of the same flip-flop 2. Let's call it timing path 2. So we have to find the maximum clock frequency or the minimum clock period so that both the timing path satisfy the setup and hold timing checks. Now let's first concentrate on the timing path 1 and let's write the setup equation for the timing path first. So the setup equation of timing path 1 is T minus T setup of flip-flop 2 should be greater than or equal to T clock to Q delay of flip-flop 1 plus T combinational delay, and combinational logic here is nothing but mux. So if we put the values in these equations, we will get T minus T setup of flip-flop 2. T setup of flip-flop 2 is nothing but 3 nanosecond. So 3 nanosecond should be greater than or equal to T clock to Q delay. T clock to Q delay of both the flip-flop is 2 nanosecond plus T mux delay. So mux delay is 0.5 nanosecond. And if we rewrite this, our T setup is greater than or equal to 5.5 nanosecond. Okay, so for timing path 1 to satisfy the setup equations, our clock period should be at least 5.5 nanosecond. Now let's see the hold timing check for path 1. So for hold timing check, the equation is T hold of flip-flop 2 should be less than or equal to T clock to Q delay of flip-flop 1 plus T mux delay. That means T hold time of the flip-flop 2 is nothing but 3 nanosecond. 3 nanosecond should be less than T clock to Q delay, which is 2 nanosecond plus T max which is 0.5 nanosecond. So here 3 is less than or equal to 2.5 nanosecond, and this is basically equation is basically not satisfying. So with the given T hold and T clock to Q delay and T max delay, we have a hold violation for the timing path 1. That means this particular circuit has a hold violation and it is not going to work at any clock frequency unless we fix this hold violation. So friends, many engineers do a mistake here and they just write the setup equation for both the timing path 1 and 2, and based on the values, time period values they get from the timing path 1 and timing path 2 setup equations, they will just say that okay, this is our maximum clock frequency. But along with that, we have to make sure that with the given timing parameters, our circuit is satisfying the hold equation as well. If with the given parameters our circuit is not satisfying the hold equation, that means the circuit is not going to work at any clock frequency. So friends, very important point to note here that always try to find out both setup and hold timing equations, whatever in the questions they are asking. So in the questions, if you see here in the questions, they are asking the maximum clock frequency. So we know that the clock frequency or the time period is only used in the setup equation. So we will just go and write the setup equation, and based on that result we will try to give our answer, but that is not always true. Along with that, we have to check the hold timing check. And so hope this question is clear. If you have any doubts, please write down in the comment section. Also, if you like this video, please hit the like button and do not forget to subscribe this channel so that you will get notified as soon as I upload a next video. Thank you very much.